Hey, welcome back to the lecture. So in the previous lecture, we were actually exploring about the UART pin configuration, right? We actually took the GPIO pins PA2 and PA3 and we actually configured them to alternate functionality mode to behave as UART TX as well as UART RX pins. Great. So now the fourth step is UART parameter initialization. So what are the parameters of UART? Like baud rate, you have to initialize the number of stop bits, whether the hardware flow control is required or not, or you have to configure the parity, etc. So all those things we have to configure now. This is basically the UART peripheral configuration. Now so far what we did was UART pin configuration. Now let's do the UART peripheral configuration, and for that we have to go to the UART.c or USART.c. Now let's go to the USART.c, and here it is, USART init. We have to initialize the UART init type depth structure in order to initialize the UART peripheral. So now let's use this API. Now let me go to the main.c, and here the first parameter is USART X. X means which UART peripheral you are using, whether you are using 1, 2, 3, 4, 5, 6, etc. The base address of the USART peripheral. And the second one is the initialization structure, the pointer to the initialization structure. Now let's go to the main.c and let's start doing. Now first let's create a variable for this structure. Now let me do that here. Alright, let me call it as UART2 init. Fine. Now let's copy this variable and let's initialize this. Right. So first one, UART baud rate. Let's select the baud rate. Now for the baud rate, let's use 115200. You can just type that number. Now after that, the next thing, UART baud rate, hardware flow control. So let's not use hardware flow control. Now what is actually the options available to configure this hardware flow control? So here you can see that you can get the reference from here. Let's search that, and here it is. Let's use none, hardware flow control none. And after that, the next one is mode. Let's see what are the options available for the mode. So we have to refer to this mode reference here, and the modes are RX mode, TX mode. Let's use both TX and RX modes. Now let's use TX as well as RX. So for that you have to use TX, then bitwise, or then you can give RX. Great. And after that, what is next? The next one, baud rate is done, flow control is done, mode is done, parity. So let's see what exactly is the parity, and the parity, here it is. So let's search what are the options available for the parity, and here parity, let's use no parity. Great. So let's use no parity. We don't want to use any parity checking. And after that, let's see what is next. So stop bits. Now let's use only one stop bits. Right, so let's use only one stop bits. Now let's see what are the options available for the stop bits. 1, 0.5, 2, 1.5. So let's use one stop bit, that is standard value. So if you are using UART at higher baud rate like 1 MB, 2 MB, then it makes sense to use 2 stop bits or more than that. Otherwise, for normal 115200 communication, which is actually an average speed, right? So one stop bit is sufficient. Now after that, let's go and check what is next, word length. So what is the word length for the message format? So let's see how many options are available here. 8 bits or 9 bits. That means one UART packet contains 8 bits of user data or 9 bits of user data. So your choice. So now let me select 8 bits. Right, that's it. We initialized everything, very simple. And after that, let's call USART init. That's it. Now first you have to mention the base address. Base address is USART2, isn't it? And because USART X, right? So in the place of X, you have to mention the number and then pass the address to this structure. That's it. So let's delete this. Fine. That is UART parameter initializations. Great. So we have to do more initialization if we want, like it's interrupt initialization. So that we'll see as we make a progress in case if you want to use UART interrupts, but for the time being, it's not required. Remember that these are local variables, so they actually contain garbage values, right? So that's why before initializing them, there may be some member elements, those are actually uninitialized. So better you make everything as 0 here. So better you initialize all the member elements to 0 before you initialize the member element. So that's why what I want to do is, before initializing here, I will use memset GPIO UART pins, and of GPIO UART pins, let me initialize each and every member elements to 0, and you have to give the size of this structure. So this is for zeroing each and every member element of the structure. Great. So now let's repeat this for UART also. Great. So here let me give UART in it. Now let's compile the code. Alright, there are no errors actually. Alright, so it actually went well. So there are no errors, but there are a couple of warnings. Let's check, because warnings are always dangerous. So here it is, implicit declaration of memset. So for that, you have to give, if I'm not wrong, std lib.h. So let's check once again. So actually you have to give string.h. So let's give string.h. So hash include string.h. Great. So yes, it went well. So complete up to here, and in the next lecture let's see how we can send some characters using UART peripheral. I'll see you in the next lecture.